Complex number 2, 4. Number 4, 4. Imagine 4. Altogether, 12. Divided by 4. 3. So, NADH, 3. Okay? That's it. Related to FADH. FADH gives its electron complex number 2. We don't have complex number 1 pumping proton, and complex number 2 also doesn't pump a proton. So we have just 3 and 4. How many? 8. Divided by 4? 2. So FADH is equal to 2. But I told you, because complex number 4, in addition actually to pump 4 protons, also use 2 protons for producing H2O. Actually use 2 protons for H2O. We can say instead of pumping 4 protons, actually it pumps 2 protons, not 4. So again you can calculate it. If you put 2 here, instead of 12, you have a 10. 10 divided by 4 is 2.5. And here, instead of 8, you have a 6. Is a 1.5. Yes. Isn't it clear? So, I'm going to explain these complexes and they function one by one. Muhammad Hassan.
Yeah.
All the time you ask what is the complexes and you are listening to the music and then you can understand the. So, if you look at here, we have a thermodynamic group. Actually, I'll talk about all of them.
I know that. I understand that.
You understand me?
Yeah.
Okay.
Because it's from the middle school.
يعطيك العافية. العافية. So, here, we called actually this using a proton gradient for producing energy known as a chemiosmotic theory, which this scientist, Peter Mitchell, actually discovered that. He discovered in the intramembrane space, we have a lot of proton gradient. And these proton gradient actually are used by ATP synthase to produce ATP. So it's known as a chemiosmotic theory. Here you can see the complex number 1, 2, 3, 4, and their name, their component. Complex number 1, the name is NADH dehydrogenase, or NADH oxidase also. It consists of FMN and iron sulfur group. FMN and iron sulfur group. So NADH gives its electron to FMN and reduces it. And then inside the complex, actually a lot of reaction occurs. So one understand, complex is complex number 1. It consists of FMN, iron, sulfur, other center, just silent your phone. And the name is complex number 1 or NADH dehydrogenase. This complex gives its electron to coenzyme Q. Both proton and electron convert to the coenzyme Q. And also we pump proton. Complex number 2, the other name is succinate dehydrogenase. From succinate to fumarate, we produce FADH. And FADH gives its electron to the coenzyme Q. And coenzyme Q transfer this proton and electron to the complex number 3. The other name is cytochrome BC1. Consists of cytochrome B, 5, 4, 8, and 5, 6, 2. And also cytochrome C1. Finally, after this redox center, they transport electron and proton together. They give electron to cytochrome C. And cytochrome C transfer to the cytochrome complex number 4, which the name is cytochrome C oxidase or cytochrome A oxidase. Finally, we use oxygen to produce ATP.
H2O.
Again, I will talk about it more and more. Come on. Here, complex number 1, by transporting electron flow, also pump proton. And complex number 3 also pump proton. And complex number 4 pump proton. Okay, finally we produce H2O. And these protons, all of them, they are going to transfer to the matrix by this molecule which is known as an ATP synthase. An ATP synthase transport proton to the matrix and create ATP photons. The F1 domain create ATP, the F0 is a channel for transportation of proton. Again, this is complex number 1, 2, 3, and 4. Because number 2 is not transmembrane and attached to the matrix site, cannot form a proton. But here we have a 4, and here 2 and 2. Okay? So, and these protons, all of them, they are going back to the matrix from F0, F1, ATP synthase. So one by one, the complexes, they are the component of complex number 1. The name is NADH dehydrogenase or NADH-Q reductase. Okay, is a huge protein, and consists of FMN, flavic-mononucleotide, and iron sulfur group. And finally gives electron to the ubiquinone. Has an iron sulfur center and FMN. Complex number 2, the name is a succinate dehydrogenase or succinate Q reductase. Also is a part of Krebs cycle. It contains FAD, iron sulfur, and gives electron again to the ubiquinone. What is the meaning of ubiquinone?
Coenzyme.
Is present everywhere. Ubiquitous is a molecule which is present everywhere, in any kind of cells, anywhere. For this reason, the name is ubiquinone. It means it's present everywhere, which is a lipid inner membrane. And complex number 3, or other name, is a cytochrome C reductase because it's reduced cytochrome C. Okay, we can call cytochrome oxidase or reductase based on the reaction. So it's contained cytochrome, BH, BL, FES, and cytochrome C1. They are component of complex number 3. And also, they transfer to the cytochrome C. Cytochrome C to the complex number 4, or other name is cytochrome C oxidase. Cytochrome C oxidase contains cytochrome A, A3, copper U, copper A. Instead of iron sulfur, has a copper, Cu. Okay? What do you call it in Arabic? Nas? Nahas. Instead of hadid, has a nahas. Okay?
So just difference between the
Is one of the differences. Also has a heme A and heme 2, and has a cytochrome A, cytochrome A3.
Well, briefly, it's a burning process by missing the electrons, right? We can describe it like that.
I didn't get what you mean exactly, but after the class we can talk about it. Hem A and Cu act together to transfer electron to the oxygen. So, is the whole pathway together? Complex number 1, from NADH to FMN to FES to coenzyme Q. Complex number 2, from succinate to FAD, FES, coenzyme Q. 3, from coenzyme Q, FES, cytochrome B, cytochrome C1, cytochrome C, and finally from cytochrome C to cytochrome A3, or finally to the oxygen. So here we have those enzymes which produce NADH for us, like glycerol-aldehyde phosphate dehydrogenase, isocitrate dehydrogenase, malodehydrogenase, protamide dehydrogenase, beta-hydroxy. All of them, they produce NADH, and NADH gives electron here. But succinate dehydrogenase, acetyl-CoA dehydrogenase, glycerol phosphate dehydrogenase, they gives electron to the FAD, and FAD gives the low complex number 2. So the last part of our actually complex are ATP synthase, or F0, F1 complexes. If you look at that, F1 consists of 3 alpha, 3 beta, and gamma, and somehow epsilon. All of them, they are part of F1. And beta subunit is responsible for production ATP. The F0 consists of 12C, A, and delta, somehow epsilon. So these 12 actually cytochrome, these 12 C subunit together provide a channel. Then proton move to the intermembrane space or matrix. Matrix. From the intermembrane space to the matrix, and like a turbine, it's turn and produce energy. And actually the idea behind the turbine may be actually take from this molecule inside the cells. So related to old value and present accepted the value of NADH, FADH, glucose, acetyl-CoA, and palmitate is here, and then it's very common.
Do we have to know A subunit or no?
What?
A subunit from the F0.
No.
Also, you must memorize that.
Which one?
These values, the old value of ATP generated and the presently accepted. Should we know those or?
Just all values, and you should know, and you know.
Yes.
Yeah, I know all values, but presently.
No, presently accepted. Presently is not accepted by us, by other. So, the last part of today's session is related to inhibitors. Why some materials, why actually air pollution is so dangerous? What do you think?
Can you please repeat the question?
Why air pollution is dangerous?
What is A?
Air pollution. تلوث.
Sorry, I didn't.
Because it can cause a lot of diseases.
Is it because this lowers, like,
Oxygen.
This also inhibits oxygen respiration?
Yes, most of these chemical toxin, air pollution, actually, most of the poison act on the phosphorylation oxidate. So you learn, if we inhibit oxidation, phosphorylation also is inhibited. If we inhibit phosphorylation, oxidative also is inhibited. Is it possible to inhibit one of them and other also work?
No.
No.
No way? How they dependent together?
Because the oxygen is needed for the phosphorylation.
No, we have a phosphorylation here, we have a ETC. How they join together?
Through oxygen.
No, by proton gradient. By proton gradient. How it's created proton gradient?
Through oxygen.
By this ETC. Okay? And ATP synthase, Allahu Akbar. Allahu Akbar. What is the time of Allahu Akbar? You live in which country right now? I don't know. Sweden. Here, this ATP synthase actually bring proton to the matrix. So, if we be able, instead of ATP synthase, bring the proton to the matrix, what we did?
The function of ATP synthesis is the same.
We separated phosphorylation from oxidation.
Yes.
So, we are doing oxidation, and also because we convert proton here, we transfer proton here, the oxidation also is happening intensively or more, but phosphorylation doesn't happen. Do you think it's a good?
No.
No.
No, at all.
I think it's good.
Did you think about the hibernating animal? What they are?
They use stored energy.
They will eat large amounts, and they store large
They
amounts
have
of glucose. So, in the form of
Fat.
glycogen, which is an adipose tissue, and then
What kind of hibernating animal you know?
Bears.
Bears. Brown bears. Bears
Yes.
brown actually. Okay? Brown bears is a hibernating animal. So during the winter, is going to sleep completely for the 3 months, for the 4 months. How is possible? By this way, by separating oxidation from phosphorylation. And when we separate oxidation from phosphorylation, the energy is going to the producing heat. Energy lost as a form of heat. We don't use it for ATP synthesis. And we have a specific protein in the beers brown beers, which transfer proton from the inner membrane space to the matrix without producing ATP. So actually, some of the scientists, they told with themselves, if we be able to do it in obese people, actually we can help them to burn their high calorie, their lipid to the heat, and they become skinny. And one of the most interested diet till now is that those diets lead to the increasing oxidation and decreasing phosphorylation. And we have some actually compound which they do. We call them uncoupling factor, uncoupler. Uncoupler or uncoupling factor. Did you hear about thyroid?
Yes.
Those actually people, they have a hyperthyroidism. They are skinny or fatty. Hyperthyroid. They are skinny. Why? Because of that. Tyrosine act as an uncoupler. And those they are hypothyroid, they are fatty. Why? Because tyrosine doesn't work, and actually they increase the calorie amount. They can't use it as a heat. And again, those people with hyperthyroidism all the time they feel is heat, is a hot. Hyperthyroidism. All the time they are thinking is hot because their body produces heat. And again, hypothyroid people all the time feels is cold because their body produces not enough.
Doctor, you mean hypothyroid that their body produce more thyroid?
I don't talk about that. I bring an example for you. You will learn it in the next semester. Just it was an example.
Yeah, I was asking about that.
No, it's an example. It's not for question. Just let me to finish my actual lecture, then we can talk.
Yeah.
This part is important for your final exam also. The inhibitor, all of them, not just one. Ultra-ketuloside is a poison. It inhibits translocase. What is the action of translocase? Here, so here for producing ATP, we need ADP. Okay? So there is a translocase here, which send ATP. Here ATP is produced. ATP should send out to outside the mitochondria, and also ADP should come to the mitochondria. So we have a translocase here which convert ADP and ATP together all the time. And if we inhibit that, also we don't have ADP and we can't make ATP also. And we inhibit phosphorylation and oxidation. So ultra-ketiglycide is an inhibitor for translocase. Oligomycin also is a poison which inhibits F0. So when we inhibit F0, proton cannot transfer, ATP cannot synthesis, oxidation is inhibited. So we have some ionophore like valinomycin and gramicin. They create a channel, or they change the actually potential, and also the proton gradient is disappeared by these two molecules. And the toxicity of cyanide is due to the inhibitor effect of terminal cytochrome, cytochrome A3 oxidase. It's inhibited by cyanide. You actually maybe saw in some spy movie, they have a cyanide pill in their mouth. When they catch by the other group, they eat it, and after a second they will die. Why? Because cyanide is an inhibitor of complex number 4. And when we inhibit complex number 4, we don't have ATP and it will die after a few minutes. Without any problem. You can do it, and I guarantee 100%.
I'll try that.
Yes. Related to uncoupler of oxidative phosphorylation, in brown adipose tissue, we have a different type of adipose tissue. White adipose tissue
And brown.
and brown adipose tissue. You learn that?
Yes.
So what is the differences between these two types?
This in the infant.
The adipose.
Or in the children.
The children.
Yes,
Children,
the-
they have a brown
The
too
brown.
much.
Yes.
Why?
Produce heat maybe?
Produce what?
Heat.
Heat.
Yeah.
How?
This will not take it.
By these uncoupling factors.
Yes.
They have one protein which is known thermogenic. Also we have a UCP1. Uncoupling protein 1. UCP1. Uncoupling protein in a mitochondria. So if we be able to increase the amount of brown adipose tissue instead of white adipose tissue, we can help obese people to lose their weight.
Yes.
And it's going to be actually advised by some nutrition and some specialists.
Because the brown adipose tissue have more mitochondria and their
Yes, they have more mitochondria.
yes.
And also they have this protein and they use energy for producing heat, not for producing ATP and making calorie. Just produce heat. They use energy to produce heat. For example, in the baby, they need to become warm and they have a high level of brown adipose tissue, especially in this area,
Yes.
in the neck. But when we are actually become older, younger,
We lose
the brown adipose tissue is less. But there is some way you can actually have a brown adipose tissue and have a health. If you do some actually specific type of food, a specific type of diet, and doing a practice enough, you can say actually maybe you
Distribution
have
maybe.
enough brown adipose tissue. So thyroxine, as I mentioned, I am Muhammad Hassan, Mr. Muhammad Hassan professor. Thyroxine is also known to act as a physiological uncoupler, as I mentioned. Thyroxine or T4, okay? For this reason, those people have a hyper or hypothyroidism. Actually, they act like these patients. Here are inhibitors. The complex number 1 inhibitor, complex number 2, 3, 4. The most well-known inhibitor actually acts on complex number 4. Carbon
Cyanide.
monoxide.
Yes.
One of the reasons carbon monoxide is so dangerous is that it's inhibitor of complex number 4.
Silent killer.
Cyanide, azide, and hydrogen sulfide, H2S. And in air pollution, we have carbon monoxide. Related to complex number 1, rotenone and barbiturate are more important. Rotenone and barbiturate. Complex number 2, carboxyl and also malonate. Carboxyl and malonate, they are complex number 2. And number 3, antimycin. And number 4, I told you. Inhibitor of oxidative phosphorylation. Ultra-ketyloside inhibit translocase. Oligomycin inhibit F0. And ionophore, like valinomycin and gramicidin, they change the proton gradient. Uncoupler. We have a physiological uncoupler and we have a poison. Poison like DNP, DNC, and CCCP. CCCP, you hear about that. CCCP, chlorocarbonyl
Mustard gas.
hydrogen. Yes. This gas is produced by all the country and lead to the actually decrease in the atmosphere is CCCP. And in air pollution also we have a CCCP, which is inhibitor of complex number 4. Sorry, is an uncoupler. And physiological uncoupler, as you saw, thyroxine and thermogenin, there are 2 physiological uncoupler. Again, you can see the site of action of these inhibitor. DNP and CCCP, they can inhibit here, here, here. Cyanide, COH2 is here, antimycin here, carboxyl and malonate here, allobarbital and retinol here.
We should know where it's working.
Which
The
one?
inhibitor in each complex.
Yes, you should know each
Yes.
actually poison, each inhibitor inhibit which site exactly.
Yes, yes.
And the final part of our session is related to mitochondria.
Unimportant, sir.
What?
It's unimportant, right?
Yeah, it is.
Yes, but just
When
please
listening, we can understand.
pay attention here. This point is important for you. We have a pathway in our body which is known as an apoptosis. What is apoptosis?
Programmed cell death.
Programmed cell death. Programmed cell death is one of the actually pathway which till now we couldn't say completely understood. But is one of the main important in the cancer. Cancer cell actually, they decrease apoptosis and actually they can proliferate too much. One of the main pathway of apoptosis is related to integrity of a mitochondrial membrane. Mitochondria is a power plant of the cell, house of power producing inside cell. If integrity of the mitochondrial membrane destroyed, it means these cells should go to the apoptosis. How they can understand that? We had a cytochrome C. Cytochrome C actually was one of the mobile part of this ATC, which transfer electron from complex number 3 to 4. If cytochrome C released in the cytoplasm, it means the integrity of the mitochondrial membrane destroyed. So cytochrome C start signaling, which finally lead to the what?
Cell death.
Cell death or apoptosis. So in apoptosis, cytochrome C is so important and start and trigger the apoptosis. So tomorrow I will see all of you should present and be awake And if I saw someone asleep, like your friend, okay, I will promise to give you the most difficult question in my life. Okay? Just tomorrow, I'll see you. Have a nice time.
Thank you.
Ustad Arad.